All right, so let's go ahead and finish off chapter 9 with this part of the video. Let's start with level 5 optimizing. So finally, we're at the level 5 optimizing. We have our systems in place, we have quality, we have our metrics, we know what's working, what's not working, and now we just really focus on improving the existing processes that we have. So even though we have a process that works, we start looking at how can we make it work more efficiently, how can we make it work more cost effectively, okay, better quality, whatever the case may be, okay. So this is the idea of a continuous process improvement. So we have a process in place, it works, but now we're saying, okay, how can we make that process better? How can we make it more efficient? So even though we have a good process, we're going to try to make a good process better, okay? And so in this, key areas, process change management. So, in systems engineering is the process of requesting, determining attainability, planning, implementing, and evaluating of changes to the system. So again, what changes are being made? How are they impacting? Documenting all of this. This is at the point that we, create knowledge databases to look at, oh, we tried this and this didn't work. We tried this and it works, so that we don't continue to try the same thing year after year with someone new in a leadership role or on a project team when we've tried it and it's failed before. Technology change management, right? Process of identifying, selecting, and evaluating new technologies, tools, methods. This is, right now, this is, looking at, okay, is cloud better than our local instances of servers? Defect prevention. So, strategy applied to software development lifecycle that identifies root causes and defects. It's the idea that, okay, we've done a couple projects, we have some different software out there, we utilize the same tools for development, and we found a defect in this program, this software application. So, wait a minute, is this same defect exist over here, and can we get rid of it? Can we proactively look at improving quality as a constant thing? So as we look at a framework for quality management, well, this should basically make sense to you. We gather input data. Now, there is that fine line between gathering too little data to make a decision, gathering the right amount, and gathering so much that it doesn't matter, because we could have gotten to the right decision with, say, 80% of data and 80% of cost and come to the same conclusion as we would at 100%. That's all part of that level 5 as well, is again improving the process, even the process of a quality management plan. We then analyze the data, we set those quality metrics, whatever they are for our organization. Again, these can be different from organization to organization. They could be different from project to project, but at this level, we're finding those consistent things that work across projects. Perform quality assurance and control. So again, going after that, making sure it's what we think they are, and then designing an improvement. So, when we find those quality issues, we're constantly trying to correct them. Now, let's also not forget the big Hawthorne effect, right? Which was just paying attention to someone changes their behavior, okay? So just paying attention, just doing the auditing of someone's work may in fact change the way they're programming. So keep that in mind as well. Focus on customer satisfaction, prevention, not inspection. That's what I was talking about with my proactive IT. We're looking to prevent versus having to react and inspect and figure out what's going on, and then fix whatever's going on, right? Improve the process to improve the product. Quality is everyone's responsibility, you bet. I like to think of quality as the bottom up, meaning the person that's actually doing the manufacturing, that's doing the programming, they're the core of quality. Even before their work is assessed by, qualitative measure to ensure quality. Okay, it's again that idea of prevention, which means we've trained the programmer to program in this way. We know that they're doing that, and thus we're not having to do all these audits to make sure it's being done. Project-oriented, product-oriented, we've talked about that. You've done homework on that. You know, standards, so reliability, usability, accuracy, performance, all of these are standards. Today we're really focusing on this one right here, security, making sure code is programmed securely, okay? Not making the same buffer overrun mistakes in every program that we build. Quality matrix from the project level, from the process and the product. Verification, so focusing on process-related activities. So technical review or walkthroughs. Again, the idea of management by walking around. You know, we got to be careful with this because we don't want to micromanage, especially creative people who are doing code, who are writing databases, etc. But we still want them to know, right, that we're managing and we're doing it proactively. Business reviews, and as we know with people, some people want to be managed more, some people want to be managed less. So there are people that want to be managed and focused on, i.e. the Hawthorne effect, in order to produce quality work, okay? At any level, manufacturing, we're not just talking about IT necessarily, although our focus is project, right? Validation, so product-oriented activity, focus on fitness and sustainability of project deliverables. Are they going to provide value for as long as we thought, you know, throughout the product life cycle? Of course, testing. Now, it's funny that we mentioned testing because we all have gotten to where we accept bad software and then testing's done, or we let them know where the flaws are and then they improve it, right? So we as consumers have actually created the issue. So control charts for statistical control, okay? So, you know, process with statistical control, a process not within statistical control, so we can see that here, you know, if we average this out, you know, we're staying average. Here, we don't have any control, so it's able to go up. It might even come down, but, you know, upper control limits tend to be the issue there, if you will. Whoops. Finally, so fishbone or cause and effect diagram. These are challenging to do, but if you notice, you know, requirements not properly defined. So we look at every aspect. We look at people, we look at their training. We look at how much responsibility we're giving them and how that works with their methodology, the way they do their work, also with how they're managed. You know, I'm often one, if you've ever dealt with customer service and they say, oh, I don't have the authority to do that, right? The more responsibility we give to people who can, you know, manage that responsibility well, the less they have to be managed, right? So, you know, that might open up leadership to be more supportive versus reactive versus managing. It might open them up to leading the organization versus leading the department, if that makes sense. You know, technology, measurements, again, we take all of this stuff into consideration for the end result, okay? A Pareto chart, burrito chart. Documentation questions, you know, hardware problems, software errors, you know, other errors, we just document them. We chart them, you know, so we can see, okay, number of calls, well, at 50 calls, right? You know, we got 82 calls relating to documentation. We got 67 calls related to hardware problems. We got 34 relating to software issues. We got 10 for the other, and of course we'd want to, you know, flesh this out. What are these 10, right? But we know here by doing this that first and foremost, if we want to reduce calls, we need to create better documentation. And then finally, here as we look at this, some additional quality control tools. So checklists, of course, flow charts. I love process flow charts. You know, if this happens, you know, we can move to this. If it's a yes, we move here. If it's a no, we come back here. These are great, especially for how data is processed through the system. You know, when it's quality checked, where it goes, what happens to it. You know, does it need to go back for more planning, for example? We can use statistical analysis. looking at, okay, where's the peaks and valleys, and where does the data really flow, and are we going to worry about this 5% here, given that 90% is within whatever range we deem acceptable. So continuous improvement, again, that level 5, use knowledge management as tools for organization and team learning. Remember, I talked about that, creating those knowledge databases so that people can look back to see what's been done. This is the really high level. This is the idea that if we lose a manager, we don't lose the knowledge of that manager. Okay, and that's a huge thing. We just lose the manager because if that manager has been required to document in a knowledge management database or whatever, what we've done, what we've tried, what succeeded, what failed, etc., we're going to be so much better off, right? And again, back down to document and disseminate lessons learned. So we are actually, instead of spending all that time on reactivity that we no longer have to spend, we're investing that time to look at what's happening, to actually look at the past and make sure we don't make the same mistakes in the future. Continuum improvement, again, we're all focused on, okay, this works well, but how can it be made better? That constant strive for improvement, okay? Project quality plan should support the organization in searching for ways to build a better product or system, whether it be even building the current system better, okay, or starting out to build a whole new system that would be, even exponentially better than just improving the existing system. But again, the more data and knowledge we have to do that, the better off we are. I'll see you for the next part. Take care.